Right, good morning, learners. In this video, we are going to look at the November 2016 question paper 2, the analytical geometry questions. That is question 3 and 4. We can start right now with question 3. Says, in the diagram, the point A, negative 7, 2, there's the point A, negative 7, 2, B, C, that is at 6, 3, C, and D are vertices of rectangle ABCD. Right, now the fact, first of all, before we even look at the questions, that they give me information ABCD is a rectangle is a lot of information. Because I know all of these lines are perpendicular to one another. I know these two are parallel and equal to one another. Those two are parallel and equal to one another, and also that the diagonals will bisect one another, and they will also be equal in length. This length and this length will be the same, and since this one is bisected and that one is bisected, all four these lengths there will be the same, meaning M is the midpoint of DB and also AC. So there is quite a lot of information in the fact that they say that is a rectangle. Then it says the equation of AD is y is equal to 2x plus 16. So this line there, given as y is equal to 2x plus 16. Line AB cuts the y-axis at G. Line AB cuts the y-axis there at G. The x-intercept of line BC is P0. There, the x-intercept of BC, P0. And the angle of inclination of BC, BC, there it is alpha. There it is given on the sketch, with the positive x-axis. The diagonals of the rectangle intersect one another at point M. Then they first of all say calculate the coordinates of M. Right, so I said M will be the midpoint of both these diagonals. Since I have the two coordinates there of the diagonals, this is not a very difficult calculation, so I can start there with the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2, and the two coordinates of A and C there is given as A is negative 7, 2 and C is 6, 3. So I'm going to just substitute these values in. Let me use this as my 1 and this as my 2. So this is x1, y1. This is x2, y2. So x1, x2 is going to be negative 7 and 6. Negative 7 and 6 over 2. And then y1 and y2 is 2 and 3. 2 plus 3 over 2. And then you can simply type that into your calculator as it is, giving you negative a half and 5 over 2 or 2.5 or 2,5, all of those acceptable. Alright, so that is the coordinates of M. Then 3.2 says write down the gradient of BC in terms of P. The gradient of BC in terms of P, so I want to use these 2 points to calculate the gradient of BC with the P value there, basically. So I'm going to work out the gradient of BC by using the 2 points. Gradient is difference in y over difference in x. These formulas on your formula sheet, by the way, where C is the point 6, 3, and that point F there is the point P0. Even though they say the gradient of BC, this is both 2 points that lie on the line. You can use any 2 points on the line to calculate the gradient. So I can also use the point F. So the gradient of FC and the gradient of BC will be the same, since they are collinear, it's a straight line. the gradient on a straight line is always the same. Doesn't matter where you take the gradient. So the difference in y is 3 minus 0. 3 minus 0 over the difference in x is 6 minus p. 6 minus p, and 3 minus 0 I can simplify just to 3 over 6 minus p. Right, so that's the gradient of BC in terms of p. And then they say, hence calculate the value of p. Right, so now I need to know what is the actual gradient of BC. Now, since this is a rectangle, this gradient here is 2. These lines will be parallel, so that gradient should also be 2. Let me just state that AD and BC, 3.3, AD and BC are parallel because they are sides of a rectangle, which the reason's not as important when you're working with analytical. Just to explain what I'm doing here, that means that the gradient of AD should be equal to the gradient of BC. In analytical, you should know, as we discussed earlier, that parallel lines have equal gradients, perpendicular lines, the gradients multiplied should give you -1. So since I have parallel lines, the gradient should be equal, and I can see the gradient of AD is 2. So then that means the gradient of BC is 2, which if BC is 3 minus 6p, but it's also 2, I can solve p by just making those two things equal to one another. So I have 3 over 6 minus p is equal to 2. Cross multiply, you can put this over 1 and then cross multiply. So 6 minus p times 2 is 2, 6 minus p, and 3 times 1 is then 3. And let's multiply this in. So I have 12 minus 2p is equal to 3. I'm going to take the 2p to the other side because I don't like working with negatives, personal preference. 12 minus 3 is 9. That means that p is going to be 9 over 2. If I divide by 2 both sides. Right. So that's question 3.3. Question 3.4 says calculate the length of DB. The length of DB going to be exactly the same as the length of AC, as I said earlier, because they told me this is a rectangle. So I can calculate the distance between points A and C and just state that BD has the same length. So calculate the length of BD. I'm going to first just state, that BD is going to be equal to AC. This is a property of diagonals of a rectangle. Really not necessary to give proper reasons here because it's analytical, but better safe than sorry. So then I can actually just calculate the length of AC. It's going to be distance formula xc minus xa squared plus yc minus ya squared, where a is the point -7, 2, and C is the point 6,3 given on the sketch. I'm just putting the 2 points here so it's easier to substitute in there. So I can see the x value at C is 6 minus the x value at A, which is -7. I'm going to make this a +7 there, squared, plus y value at C is 3 minus the y value at A, which is 2 squared. And then, well, you can just type this into your calculator actually. So I have there, I'm just going to quickly type it into my calculator. I'm just going to type in there 6 plus 7 squared, plus, and 3 minus 2 is 1, so 1 squared. And that gives me root 170, which I don't actually want to leave like that. I would rather press this SD button, standard to decimal form, and just rather change it to decimal form and give the answer as 13,04, rounding off to 2 decimals. So 13,04 units, I suppose. Right. Okay, so that is question 3.4. We can move to question 3.5. Question 3.5 says calculate the size of alpha. Right, now this has to do with inclination. Alpha, as they actually said in the beginning, alpha is the angle of inclination of BC. So to calculate angle of inclination, this is also on your formula sheet. This is grade 11 work. Well, most of it in this question is grade 11 work anyways. So from grade 11, inclination, tan alpha is going to be the gradient of that line BC, which the gradient of BC I already stated earlier is 2, since AD is also 2, that will also be 2. So tan alpha is 2, and then alpha is going to be shift tan 2, giving me 63.434, which I can round to 63.43. 63.43 degrees. Okay, and 3.6 says now, calculate the size of angle OGB. OGB is this angle there, which, okay, there's quite a few things you can do to calculate this angle there. OGB. Okay, so one thing I always tend to do that I go back on when working with inclination angles is you can draw a little cast diagram there, right? And understand that this there is the angle of inclination. Alright, so you can work out the angle of inclination of that line, but then you also need that angle there, and to add it to that line. And well, you're going to have to work out the angle of inclination, subtract this part, and add that part, which just seems a bit extensive to me. Something else we can maybe look at is to try and find an exterior angle that's maybe equal to an opposite two interior angles. This is not an exterior angle of a triangle there though. So, well, I'm just trying to show you some thought processes here on what you can think of. Is to try and work with angle of inclination there, but I need this OGB. Or if I can find maybe that angle and that angle, I can work with inside angles of a triangle. That angle will be equal to that angle. There's just some ideas. Here is something that you can maybe look at is, I don't really see triangles that you can work with. This one is exterior angle, but it's not a triangle, it's like a something. So maybe look at this quadrilateral here. Triangles doesn't seem to give me answers. So maybe I can look at this quadrilateral there. And of course, since this is the x and the y axis, that's a 90-degree angle. And since this is a rectangle, that is a 90-degree angle. And these ones are vertically opposite. So that's alpha, this is alpha. And then the inside angles of any quadrilateral adds up to 360 always. So I can get that angle OGB by taking 360 minus 90 minus 90 minus alpha. Well, that's something I can do. Okay, so let's do that. I suppose there's quite a few ways in which you can get that angle OGB. I'd be interested to hear if any of the learners in the viewers, if any of you who's viewing this video saw something else to do, please share it with us in the comments down below, just for interest's sake. I like it to know if there's more than one way to answer. So what I can do is say OFB. OFB will be equal to alpha, which is 63.43, and I think just because there might be more than one way and the person marking doesn't necessarily see my way, I'm just going to also state that FOG is 90, axes are perpendicular, and then OBF is also not OBF, GBF, sorry. GBF is also 90 degrees. Angles of rectangle. Wait, how do I spell rectangle here now? Okay, a rectangle. That means then that OGB, which is the angle that I'm looking for, must be 360 minus 90 minus 90 minus alpha. Because like the angles of a triangle add up to 180, the angles of four sided figures add up to 360. So, well, 360 minus 90 minus 90 minus alpha, which is 63.43, is going to give me 116.57. 116.57 there. All right. Question 3.7. Determine the equation of the circle passing through the points D, B, C in the form x minus a plus y minus b is equal to RC. Is equal to R squared. So D, B, and C. There's D, B, and C. Now, obviously, since that's 90 degrees, dB is this diameter of the circle, making M the midpoint of dB, the center of the circle, right? Okay, so I'm just going to state here that since that DCB equals 90, that makes dB is the diameter, because of that angle in a semicircle, converse of angle in semicircle makes dB the diameter, makes M the midpoint. All right, which means I already calculated M earlier as negative half 5/2, which means A and B, the midpoint, is equal to negative half 9/2. All right, then I need the radius. So if you look at the sketch, if M is the midpoint, C lies on the circumference, that's the length of the radius, or that's the length of the radius, or that's the length of the radius. So, well, basically half of dB. And I also calculated the length of BD earlier. as 13.04. So dB is the diameter, which is equal to 13.04, meaning the radius is equal to 13.04 divided by 2, and that gives me 6.52. Right, so the radius 6.52, and typically in the equation of a circle, x minus a, which is negative a half, going to make that plus a half there, plus y minus b, which is then 9/2 squared, is equal to radius squared. So I actually need to take this guy there and just square it. So 42.51. I'm just going to also put it there just for the person marking, if there's a mistake somewhere, that you can see this is what I got as my radius, this is what I got as my radius squared. If this does not if this is not the same as on his memo, maybe I made a mistake there somewhere, but he can at least see that I worked out the correct thing here to still get the marks. Alright, so x minus a squared plus y minus b squared is equal to radius squared. There's my circle equation. 3.8. Last question in this question, before we move to question 4, is if AD is shifted such that ABCD becomes a square, will BC be a tangent to the circle passing through points A, M, and B? Yoy, that's insane. Where M is now the intersection of the diagonals of the square ABCD. Motivate your answer. Okay, so what they're asking here, I'm just going to move on the sketch as well. If this line AD here is shifted so that ABCD becomes a square, so obviously I'm going to make this shorter so that it becomes a square there. Then they want to know, will BC, this line here, be a tangent to the circle going through A, M, and B? Will this line be a tangent to that circle? So what I want to know is if this line is moved and the M moves with it, right? So they say where M is now the intersection of the diagonals of the square ABCD. So if I make this shorter, such that I have a new figure that's a square with the same points A, B, C, D, and M. So basically, let's just keep the sketch as it is and imagine ourselves this is a square now with, then they want to know, is this line a tangent to the circle going through these 3 points? Now, for a tangent, I know tan chord theorem, so the tangent, the angle between the tangent and the chord must be equal to the angle formed on that chord. So this angle must be equal to that one, which for a square it is true. If you know your properties of a square, not only in a square is this all 90 degrees, but also these angles will be 45, 45, 45. Not for a rectangle, you can clearly see these are not the same. But if this is a square, all 8 those angles there will be the same, exactly 45 degrees. So, will this be a diagonal, a tangent? And motivate your answer. So I can just say yes, because angle MBC is 45, and angle MAB will also be 45. That's properties of the angles of a square. So the converse of tan chord theorem I used here. Tan chord theorem. Let me just quickly explain that the converse. The tan chord theorem says that if these 3 points lie on an actual circle, and that's a tangent. So if this is a circle and that is a tangent, these two angles will be equal. That's the tan chord theorem. So what I've done here is I've argued that this is 45 and that is 45, meaning the tan chord theorem holds up. So this will be a circle with that as a tangent then. So yes, it's a tangent because of the converse of tan chord theorem. Right, that's question 3. Let's look at question 4. So I have here in the diagram, M is the center of the circle passing through T, that's the point 37 there, R there, and S the 0.52. And since they tell me it's a diameter, I can somewhere mark in that's going to be 90 degrees. And also if they tell me this is a tangent, which I suppose they will do, that KTL is a tangent to K is a point in the fourth quadrant such that KTLT is a tangent at T. So if this is a tangent, also that will be 90, right? Because a diameter and a tangent, or a radius and a tangent, is always also perpendicular to one another. A lot of Euclidean coming through in these analytical questions. Okay, so RT is the diameter of the circle. RT. Okay. KIB is a point. I've got that already. And that's a tangent. Great. Give a reason why TSR is equal to 90. TSR, that one is equal to 90 because it's an angle on a diameter or angle in semicircle from Euclidean geometry. Then question 4.2, calculate the gradient of TS. TS is this line. I have the point T as 37, the point T as 37, and the point S as 52 was given to me. So calculate the gradient of TS. I'm going to use difference in Y, YT minus YS, over difference in X, XT minus XS. Is going to be Y value at T is 7 minus the Y value at S is 2 over X value at T is 3 minus the X value at S is 5. And this is then 5 over negative 2 or negative 5 over 2. Right. Okay. 4.3 now says determine the equation of the line SR. Now if I have the gradient of TS, SR, which is perpendicular, I know in analytical geometry that perpendicular lines, the gradients multiply to be -1. So the gradient of SR, if I want to find the equation of SR, the gradient of SR is times the gradient of TS, which I just calculated, should be -1 because I have perpendicular lines, right? So I can use this to calculate the gradient of SR times -5 over 2 is equal to -1. Then the gradient of SR is -1 divided by -5 over 2, which is going to be positive 2 over 5. Gradient of SR, 2 over 5, and the point 52 lies on this line. So I can substitute the point 52s with my gradient into a normal line equation. You can use either option. I like working with mx plus c. So the y value is 2, the m value is 2 over 5, the x value is 5, and I want to calculate the c. Which is going to give me a C value of 0. Let me just double check. If I take this over, I'm going to have on the other side 2 and subtract this 2 over 5 times 5. It's 0. Okay, right. So the C value is 0, meaning the line is y is equal to m, which is 2 over 5, mx plus c, which is 0, and I don't need to write plus 0 there, so that. Right. Question 4.4. There's quite a big part of question 4.4. Says the equation of the circle above is x minus 9 squared plus y minus 6.5 squared is 36.25. Give the length of TR in third form. Right, so the length of TR, obviously then the coordinates of M is going to be 9, 6.5, yes, because that's minus 9 minus 6.5 is going to give me the coordinates of the midpoint of the circle. The length of the radius, the length of TR, you see TR is the diameter, so the length of the radius is 36.25, the radius squared, actually, the radius squared is 36.25, meaning the radius is going to be root of 36.25, which I would just actually like to write in improper fraction form. 36 times 4 is double, 72, 144. Can that be correct? 72, 144 over 4. 144 plus the 1 is 145 over 4. So the radius is root of 145 over, and square root of 4 is just going to be 2. And they say I can leave it in root form. So I suppose calculate the length of TR. Okay, this is the radius, right? This is the radius. So TR, which is the diameter, is going to be double this, since this is root 145 over 2. If I take 2 times root 145 over 2, the 2's will cancel, leaving me only root 145. So TR root 145. 4.5. This is 4.4.1, sorry. So this is 4.4.2. Says calculate the coordinates of R. Alright, so I have the midpoint of TR. I have T. It's not difficult to calculate R. What's going to happen with this is midpoint formula, obviously. The midpoint of TR. This is 4.4.2. 4.4.2. I just think I'm going to start on a new page because of space. So the coordinates of M, which is the midpoint of TR, is going to be xt plus xr over 2 and yt plus yr over 2. Then M is the point 9, 6.5, which also 6 times 2 is 12 plus 1. I'm just going to write as 13 over 2 instead of 6.5. 13 over 2 is equal to xt is 3, and I want to calculate xr, and yt is 7, plus I need to calculate yr as well. So from this I can see that 3 plus the x value of r when divided by 2 should give me 9. I can split this up into this should be equal and this should be equal, right? Two separate questions or sums. So I have 3 plus xr over 2 is 9, and then multiply the 2 on the other side to get rid of it. So I have 3 plus xr is 9 times 2 is 18. So xr is going to be 15, right? If I subtract, and y7 plus the y value at r over 2 should be equal to 13 over 2. Then if I multiply by 2 both sides to get rid of the 2's there, I just have 7 plus yr is 13, and then yr is equal to 13 minus 7, which is 6. So that makes the coordinates of R 15, 6. Alright, that's 4.4.2. 4.4.3 says calculate sine R. Sine R. Sine is going to be length of TS over length of TR, which I think I already have the length of TR as root 145. I need the length of TS. Have I not calculated that yet? I got the gradient of TS. I don't have the length of TR. So, I mean, it's not really difficult to get. 4.4.3, the length of TR is going to be, I'm just going to quickly 3752. I have TS. Sorry. I'm trying to calculate TS. So T is the 0.37 and S is the 0.52, and I'm going to use the distance formula. So the square root of difference in X 5 minus 3 squared plus difference in Y 2 minus 7 squared, and I can just use my calculator there. Square root of 5 minus 3 is 2 squared plus negative 5 squared, and that gives me root 29. Okay, so root 29, and then sine R is going to be opposite TS, which is root 29, over hypotenuse TR, which is root 145. And technically, you don't want to leave it in root form, so you should do root 29 times 145 over 145. But I think they don't mention here without the calculator anywhere. So instead of this, what you could also just do is just type that into your calculator. So I have root 29 over root 145, and it gives me root 5 over 5 if we simplify, because this is going to take a few steps to actually simplify to that. So just calculate the root 5 over 5, or I mean you can even write 0.45447, 0.45 as an answer. I prefer decimal answers above standard form. Then question 4.4.4, show that B is equal to 12a minus 29. B is equal to 12a minus 29. Okay. Do I have the gradient of TR so far? I have the length. Okay, I think I should use the gradient of TR here. And then the fact that the gradient here is perpendicular to that gradient. And then that gradient is going to be B minus 7 over A minus 3. And then from there, if I just solve the B, that should produce the result. So let's do that, but it's only 3 points, so there might be a shorter method. But okay, that's gonna work anyway, so I'm gonna start with that. I'm gonna start by just working out the gradient of this. Well, you can work with TR or TM. So the gradient of Tm is going to be difference in y 6.5, or 6.5 minus 7, 6.5 minus 7 over difference in x 9 minus 3, and you can just type this into your calculator. Whenever you work with mixed fractions in your calculator, please use the shift fraction option that produces the mixed fraction. Don't type, let me just show you wrong first. Don't type 6 and then put a fraction there, or put the fraction and then type a 6 there in front. That's going to produce, so you see here I have 6 and then I have a fraction next to it and a half, but I typed the 6 there without being without a block there. What this is going to do on the calculator is take 6 times a half if you type numbers next to one another, which you actually want 6 and a half, which is 6 plus a half. So you must use the shift fraction button. But you see I have a space there to type the 6, and then I type a half. 6 and a half minus 7 over 9 minus 3, and the gradient is negative 1 over 12. Negative 1 over 12, right, which is the gradient of Tm. And if the gradient of Tm is negative 1 over 12, this is going to be a gradient of 12, because the gradient of Tk times the gradient of Tm, which is negative 1 over 2, should be negative 1. I have perpendicular lines, and that makes the gradient of Tk 12. Negative 1 divided by negative 1 over 12. So the gradient of Tk is 12. The gradient of Tk is also equal to difference in y, which is b minus 7. B minus 7 over difference in x, a minus 3. A minus 3 is equal to 12. And then let's multiply this on the other side. So I have b minus 7 is equal to 12 times a minus 3. And I want to have b is equal to. So I'm also going to take that to the other side. B is equal to, let's multiply there, 12a minus 36 plus 7. And that gives me b is equal to 12a minus 36 plus 7 is minus 29, I think. Yes. Okay, 12a minus 29, and that is what they wanted me to show there exactly. Alright, and last question here, if tk is equal to tr, if tk is equal to tr, calculate the coordinates of k. Okay, I have the length of TR somewhere. The length of TR 4.4.1 was root 145. Root 1 TR root 145. So for 4.4.5, 4.4.5, if TK is equal to TR, TK is equal to TR, that means that's equal to root 145, right? And then, well, you can just use the distance formula with these two coordinates there. So TK is going to be root of difference in x, a minus 3 squared, plus difference in y, which is b minus 7 squared, and this should be equal to root 145, which I can substitute in there then. Root 145 is root a minus 3 squared plus root b minus 7 squared. And since there's now a square root on both sides, you can just drop the square root. But even then, so I still have one equation here with an a and a b. I need another equation, which they assisted me with in the previous one. So the previous question, they actually helped me that b is 12a minus 29. So I can replace this b there with 12a minus 29 minus 7 then squared, and now this is just a in the equation. You see I dropped I left out the square root since they're both sides. I just squared both sides, and then I also just replace the b with the 12a minus 29 from the previous question. And now this is a quadratic equation which I'm going to multiply the a minus 3 with another a minus 3, giving me a squared minus 6a plus 9. And this is 12a minus 35. Let me just double check. Minus 29 minus 7. Minus 36. So also 12a minus 36 is 144a squared. 36 times 12 is minus 432, so minus 864a, and then 36 squared is going to be 1296. If you need to write the bracket twice in order to solve, and then I also must jump over the 145. Okay, if you need to write the bracket twice and multiply out, that's perfectly fine. Let me just actually double check this one here quickly. That one is not insane, but this one a bit risky. So let me just double check. 12a minus 36 times 12a minus 36. Then I have 12a times 12a is 144a squared. 12a times 36, 12 times 36 is going to be 432, so that's going to be negative 432a, and 36 times 12a also negative 432a, negative 432a, and then 36 times 36 is 36 times 36 is 1296, which is going to be added there. So I have the 144a minus 432 minus 432 is that, and then the 1296. Okay, all right. So a squared 144 plus that a is going to be 145 a squared. The a values, it's minus 6 minus 864, that's it, so that's minus 870, minus 870a, and then just the number values is 9 plus 1296 minus 145, which is 1160 plus 1160. Right, now I notice that all of this can be divided by 5. It might even divide by 15. I mean, you can simplify this a little bit before you try to factorize, but even so, I'm just going to use the quadratic formula. So I'm not even going to bother with simplifying this. So a is going to be, you can write out the quadratic formula if you're not comfortable with it. I'm just going to type it in my calculator. Minus b, which is negative 870. So minus negative is going to be positive 870, plus or minus, I'm just first going to take a plus, root of b squared, negative 870 squared, minus 4a, which is 145, c, which is 1160, over to a, which is 145, and this gives me 4, or a is equal to, I'm just going to change that there to a negative, and that gives me 2. Oh, so simple. Okay, so a is equal to 4 or 2. I'm trying to calculate the coordinates of a, right there. Now since that is a 3 there and this has a positive gradient, that just means that there's also a line with the same distance that I can draw to the x-axis that's going to be cut there at 4 and that's going to cut there at 2. I can see this is before the 3, right? Since the line is going forward like this. That value should be before that value. So this is going to be 2, right? that one is not applicable. And then the B I worked out earlier as 12a minus 29. So if the A is 2, I have 12a, which is 2 minus 29, negative 5. So the B is negative 5. Calculate the coordinates of K. K is 2, negative 5. Okay. All right, and that concludes the questions from the November 2016 paper on analytical geometry. I hope this was useful. Have a good day.